This video is going to look at reading various types of graphs and even constructing some. So the first graph is a bar graph, which we're all pretty used to seeing in reading and analyzing, so not too difficult to start with. So it says approximate the number of endangered species that are birds. So you would find your birds category, which happens to be right there. You would come up and it's about right there. So it says approximate, so you could say anywhere between 77 to 79. 2 says which category shows the fewest endangered species. So you would find the bar that is the shortest, and that would be right over here. You could do the same thing if it asked which shows the greatest. You would find the bar that is the tallest. Pretty simple. A scattergram may be something that we've seen, whether we've just seen it and looked at it, or we maybe remember some ideas of it from math classes in the past. So when we're looking at scattergram, we're looking at this paired data. So paired data, so that's data that can be represented as an ordered pair. So in other words, it has something such as at this time, I have this many, or at this weight, I'm at this height. At this temperature, I sell this many coats. At this weight of a teacher, we have that type of a salary. So you're looking at two things that are putting together to represent this one paired data. A scatter diagram is the graph that shows all these paired datas as points. And I have 3 examples that sit down here for you. So it could look like any 3 of these. This one has a positive distribution. This one has a negative distribution, and that's because this one has an upward trend. So as your weight increases, you're typically taller. And then here a negative, so as the temperature increases, your sales are going to decrease, which makes sense. And then the weight of a teacher and the salary, if you notice that this one has no real trend. So we could, say that there is no trend. You could say it's neutral. You could see it as a couple different words, but ultimately it does not matter the weight of the teacher. That is not going to impact their salary, which that's kind of a funny example, but it gets the point across. So you could have positive distributions, negative distributions, or this no trend or neutral. So let's look at one and let's go through the steps on how do we create this scattergram. So we're looking at this table, and this table gives the number of tornadoes that occurred in the United States for the years shown. So we have our years and we have our number of tornadoes that correspond to that year. So the first step we have to do is take this table and write it as paired data. So we're going to do it as year is your X, number of tornadoes is your Y. And pretty much 99% of the time, your X is going to represent your time. So whether you're talking about years, whether you're talking about hours, minutes, days, it's going to be your number, your time dimension or your time measurement. So our ordered pairs are going to be exactly this. So 2007, 1096, 2008, 1692, 2009, 1156, 2010, 1282, and so on. So we have 1, 2, 3, 4, 5, 6 ordered pairs. Okay, so now that we have our ordered pairs, our second step is going to create this scatter diagram of the paired data. So we have this first quadrant of our XY coordinate. Okay, so we're going to create this right here. So start with your X. So this is my X, and this is my y. So down here we have years, and then we have number of tornadoes. All right. So our x, notice that our x goes up by 1. So we have this kind of nice scale. So because this x has a scale of increasing by 1, we can use them exactly how they are. So we got 2007 through 2012. So I'm going to go ahead and ideally, you would want all of these to be equally spaced, but since we're making it by hand, we're going to have a little bit of human error in there. Okay, so again, our scale has to be by the same each time. So our x had that nice scale, but notice now for our y that there is no common increase or decrease among these y's. Okay, so from here to this first, it increases, but then it decreases, and then it increases, and then it increases some more, but then it decreases. So there's no real pattern there. So when I go to put it on my scale of y, I can't just start listing them. I have to figure out a scale. So my lowest is 939. My greatest is 1693. So whatever I put on this y-axis has to be able to accommodate that range. So I'm going to start 930 because that's the rounded down to the tens. You could start at 900. You could do 935. It just depends what you do. But then when I go to do my scale, I have to increase by the same amount as I make these hash marks. So I'm going to have to go to about 1700. And then that would fit this range that this table is at. Right? And when I do it, I'm going to go up. I'm just going to go up by hundreds. So let me erase these and start. So we got 930. Now, sometimes this takes some trial and error. So I might find that I put my scale on there and I don't have enough space. So then I have to take it back down and start over again. So making these by hand can have some trial and error, but we just have to kind of work through it. So then I have 1030. You know what? I'm going to change that because I don't like the way that looks already. So let's do 900 to 1700. So we'll start at 900 and then I'll go to 1000. And then I got 1100, 1200, 1300, 1400, 1500, 16, and then lastly. Okay, not too bad. So I like the way that looks better, just going from an even 900 to an even 1700. Yeah, okay, I like the way that looks. So now that I have, this scales, I can go ahead and plot my points. So we'll start up here at the first one. So 2007 was about 1096. So I would come up here. So that's 1000. I'm not quite at 1100. So I'm going to put my dot about right there. And again, I'm estimating, I'm guesstimating, using kind of reasoning to place that dot. Then 2008 is 1692, so that one's way up here by the 1700, so we'll put it up here. All right, 2009 is 1156, so that's a little less than 12, so we'll put it down here roughly. Yeah, it's a little bit more than half, right? All right, and then for 2010 was 1282. So we'll put it slightly down from 1300. 2011 is back up again, slightly higher than that last one, but just by one tornado. And then 2012 was 939. That was my lowest, so it's slightly lower than half of that. Put it about there. Okay, so again, I make sure that I have 1, 2, 3, 4, 5, 6 ordered pairs, 1, 2, 3, 4, 5, 6 dots on my graph. Okay. All right, so reviewing this step, creating, we have to make sure our scales are the same. So whether they increase by 1 or increase by 100, it's as long as they do that by equal hash marks. And then once I have my scales and I like the way they look, then you're just plotting or guesstimating about where these ordered pairs would fall, so then we can see the idea of the scattergram. So when we look at this, I did this scale by 50, so you could see how that would look here. My hash marks were a little slower, but it's about the same either way. Okay, so now that you have your scales and you have all your dots, you can answer 3. What trend in the paired data, if any, does this scatter diagram show? Well, remember we would have an upward if all the dots had this nice consistent upward trend. That's a positive trend. It does not. We could have this negative trend, so do all of our points have this, they start high but then they decrease over time? It does not. So it has this no trend or this neutral. So there is no trend in this, and it makes sense. Again, this is kind of a silly example, but it again gets the point across of what these no trends look like. So can we predict how many tornadoes we have in a year? No. Do we get more tornadoes over time? No, it just depends on the year and depends on the weather. So it doesn't make sense to say as time increases, the number of tornadoes increase, or as time decreases, our number of tornadoes decrease. So then eventually, would we get to ever having no tornadoes? The answer would be no. Again, it just makes sense for it to be no trend. But that's what a no trend scattergram would look like. That's the process you would go through to make a scattergram. Okay, so I'm not going to ask you to make one, but I am going to ask you to kind of use what we've learned to interpret it. So go ahead and pause, use this Old Faithful eruption. So it's a volcano. We have our eruption duration, so how long did the duration or the eruption last, and then the wait time between the eruptions. And that's what we have there. So go ahead and pause it, see if you can answer these 3 questions, play them, and then I'll go over the answers with you. Okay, so what trend does this scatter diagram show? That would be a positive trend. So as the eruption duration increases, as it gets longer in time, the longer wait time you have. What would you estimate the wait time between eruptions? That lasts 3 minutes. So find your 3 minutes. Go on up. We would be about here. So you could have said anything around 65. So anywhere around 65. Okay, and that would be minutes because that's our scale. So what would you predict to be the eruption duration for a wait time of 45 minutes? Okay, well this one, we got 45, so that'd be about right down here. And if I kind of continued this trend, it would be, we could say, you could have said 1.5, you could have said something a little bit lower because it probably would have been a little bit lower than that. So you could have said anywhere from 1.2 to 1.5, roughly, give or take. But we could continue this trend to figure out where would that fall, and it would actually fall right a little below that. Okay, so we can use that same idea as the bar graph, using the X and the Y to make these predictions, as well as knowing the trend that a scattergram shows. Very good.